So I hope you had a chance to work through the skipn problem up through the template stage. If you didn't, there's nothing I can do about that, of course, but remember, you learn more by doing than by watching. Here's my solution up through the template stage, and let me just point out a couple of parts of it that I think are worth noting. The signature was fairly straightforward. The purpose was fairly straightforward. Let's just look at the tests for a second. In the tests, remember that we're going to end up doing a structural recursion here. So I put in a test case for empty. You don't necessarily need to do that at this point in the course, but I took the trouble to do it here. And the other thing is, as I was working, I realized that n could be a number like 2 or 5 or 1, but n could also be 0. And that basically means include the whole list, because you include A, and then you don't skip any elements. You skip 0 elements, you include B. You skip 0 elements, you include C, and so on. So I've got test cases here for n of 0, 1, and 2. And then the template, well, if you look at this template, if I use a little video editing magic to highlight things here, you can see that there's the part of the template which is the original structural recursion. There's the part where we wrapped it in a local, surrounding function, and a trampoline. And there's the part where we added the accumulator parameter. And I really want to encourage you, when you look at templates like this and when you look at the resulting code, to learn how to see them as composed of those 3 distinct parts, as opposed to seeing them as composed of a whole bunch of characters. When you can see latent structure like that in code, it's really going to help you be a designer and understand code that other people write. This ability to see structure is one of the things that separates people who are quite good at this from people who type and pray. So here we go. There's our template. The next thing we need to do is we need to talk about the type of the accumulator. And what's the accumulator going to be? Well, maybe I can't guess right away what the type will be. Let's pretend I can't guess right away what the type's going to be. Let's do the invariant. And let's even do the examples. Suppose we call skip n. Suppose we make this outer call to skip n right here. Now let's do this one. And just because it's a bit too long, let's not do E and F all the way. So let's see, that's the outer call. And this is going to be the first call to the inner function. So list will be just like that. And we don't yet know what the accumulator will be. And let's just set up a few of these. So right now what I'm doing is I'm working out the examples. I'm pretending that I haven't thought of what the accumulator type should be. I'm going to work out the examples. And maybe you haven't thought of what the accumulator type would be, in which case you're not pretending, and that's great. So let's see, I'm working them out like this, and I'm indenting this way because I'm a Virgo. Now, let's think about this. If the original number to skip is 2, then, I needed to repeat. Oops, I made a little boo-boo here. I missed one line because that line corresponds to the outer call. I need this line to correspond to the first inner call. I'll put a break between them. So let's see, we're going to include A. But we don't include B. I'll just write them like this. We don't include C, and we include D. And it's kind of like we include the first one every time, but then we don't include this one because we have to skip 2. So this is the first one we skip 1. This is the second one we skip 2. Or if we want to, we can think about it as a countdown. We need to skip 2 more here. We need to skip 1 more here. We don't need to skip any here. So if we thought of it as a countdown that way, then that accumulator value there could be 2, meaning skip 2 more. That accumulator value could be 1, meaning skip 1 more. That accumulator value could be 0, which meaning skip 0 more, include this one. The next accumulator value would go back to being 2 because we're skipping 2 in this call to the outer function. And the original value would be 0 because we're including the first one. We're skipping 0 more when we get to it. I've laid out this way of working out the examples of the accumulator this way. If you wanted to draw it on paper, you could maybe work it out this way. But one way or another, you have to kind of figure out what the accumulator is going to be. Now notice I did it as a count down. You could, of course, do it as a count up from 0 to 2. That's fine as well. But now I really know what this accumulator is. Its type is natural, and its invariant is the number of elements to skip before including the next one. Now I'm ready to code the details. So let's see, when the list is empty, what result do we produce? Well, we produce empty. Well, sometimes we include and sometimes we don't include. So there's an if. And what's the question? Well, the question is the accumulator 0? Because we're going to include that one there and that one there. So if the accumulator is 0, what do? Well, we include the first item on the list in the natural recursion. And if the accumulator is not 0, what do? Well, in that case, we don't include the first element of the list in the natural recursion. Let me just fix up my parens here a bit. So that's the basic structure, but now we need to initialize. We've exploited the accumulator right there. We also need to initialize the accumulator. Well, what's the initial value of the accumulator? Well, my examples tell me that that's 0. What do we do to the accumulator in each recursive call? Well, let's see. When it's 0, we reset it back to how many numbers we're going to skip. That's this case here. And when the accumulator is not 0, in other words, on this line and this line, we just subtract 1 from it. What's up with my parens? Oh, now they're happy. Let's try it. Oh, my parens are still not happy. Look, my if isn't balanced right. I should have noticed that when I did the indent. Now let's see if my parens will be happy. I'll do Command I to fix the indentation. Yes, that now looks good to me. Now let's run it. All 4 tests passed. So this problem is a lot like skip 1. That's why we've got it here. But this time the accumulator is a little bit more complicated. This time the accumulator is this countdown. There's another very natural way to do this, which is to have the accumulator, instead of being how many more elements to skip before you include one, so you're counting down, you could have the accumulator be how many elements have you skipped since the last element that you included, in which case the accumulator would count up. What you might want to do now is go back to the template stage and finish this function with that count up version of the accumulator. Because it's really important to understand that when you work out an accumulator, you have to figure out what information to represent. And there's multiple ways to do it. Okay? This answer I have here isn't the right answer. This answer I have here is a good answer. Counting up would also be a good answer. So at this point, I think you're set to go look at some more accumulator problems. Specifically, you need to look at problems that are context-preserving accumulator problems. Work a few of those before starting the video that talks about tail recursion and accumulators for tail recursion.